Uh,
All right. Thank you, Nilesh. Thank you for doing this. I believe you are in New York.
yeah. Currently, I'm working out of New York. Yeah.
Thank you for doing this bright early morning for you. Thanks for accommodating the audience. Thanks for doing this. I'll just do a quick 1 minute intro to everyone on Atoms, which is our program, and then I'll follow that up. I'll just leave the floor to you. It's all about InfoLess. I'm actually very keen. Just before this, like 1 hour ago, I was having a chat with one of the companies, and they were talking about, Priyank, can you get us compute? And I'm like, okay, maybe serverless is the way for you. And you won't believe this. They told me that what they've done is they bought like one RTX card and then rigged it up in their home, and then they're using that as the server for. I'm like, okay, that's one way to do it.
Right.
So it should be interesting. Okay, so
And
let me.
I've seen, so that I think is not an uncommon pattern, especially in the GPU world. Like I've seen a lot of those. Yeah.
Yeah, and then last few days has been all talk about GPU poor. Liver. So without, like, I'll just take a minute. So folks, we are doing these webinars as part of Seed to Scale. This is our Seed to Scale is really a community initiative, and Accel is just helping curate it out. Folks like Nilesh and other speakers we are really grateful for them to give us their time. I just want to introduce everybody to Accel Atoms. Accel Atoms is a very early stage accelerator which Accel has launched. This is our third version. It's essentially like a 6-month hybrid program, 5 companies per cohort, and it's for basically India, Southeast Asia founders. We have 2 cohorts, so 5 companies per each, maybe more. Hopefully, if we can get more companies. So AI cohort, which I am leading, and Industry 5.0 cohort. So AI is more bits and bytes. Industry 5.0, affecting the real world, and which Bharat, who's my other partner, he's leading the Industry 5.0. And at least in the AI cohort, this is how we think about this. So, access to experts and meetups, which we do out of our Bangalore office. And a talk like this is for everyone. If we invest in a company, we are investing up to $500,000. Plus, you get a lot of credits up to 5 million. Some compute credits as well, which are much sought after right now. So AWS, Google, and Azure are partners with us. I think more importantly, everybody gets access to the Accel network, which is 250 plus in India, Southeast Asia, as well as our global Accel network. And moreover, we are also starting to have customer access, like talking to CIOs and design partners for very early stage companies. So if you or any of your friends are looking to raise capital in AI or in Industry 5.0, please feel free to reach out to us and apply to Accel Atoms. So the website is at atoms.accel.com. Sorry, the URL is wrong. I just fixed it. So it's atoms.accel.com. That's one. And we of course have Seed to Scale, where we experts like Nilesh himself, we like to showcase their knowledge, and we have co-authors from other funds as well as companies which might or might not be even invested by Accel. So that's what we're trying to do. We have invested in 24 companies in the past 2 cohorts, and they have raised around $160 million in follow-on funding and original funding across multiple investors. So that's a quick and short intro of Accel Atoms. But on to the main agenda for today. And again, thanks to Nilesh, he's joined in from New York early morning. All about serverless GPUs. So everybody knows serverless, I guess, but floor is yours, Nilesh. Please help us guide this topic.
Awesome. Thanks, Franz, for again very kind words and like a great introduction. And then again, I want this session, like I have like some slides in text, but again, I want it to be very Q&A heavy. The idea is again to like talk about like what serverless GPU is, when you should actually go for it, when it's okay or maybe does not make super urgent sense, right? And then what are some of the things of like doing things like Priyank said, like building your in-house infrastructure, right? What are the pros and cons that come with it? So again, at the end, right, you should all definitely know about things. And then again, it's like at the end, your decision, right? Cool. So I'll just quickly share my screen and I'll probably start with a little bit of introduction about myself. Are you folks able to see my screen?
Yes, we can.
Cool. So a little bit about me again. I'm currently the co-founder and CTO of Infiless. Before this, I have worked for companies like Amazon and Trilogy. In both stints of them with Amazon, I spent most of my time in the team which used to do automated advertising. So anything that you see Google ads bothering for Amazon products, that was our team. We had like 50 million running across, like 50 million ads running across 16 countries back in 2018. They must have scaled from there on. Also before that, I also worked for this company called Trilogy Group of Companies. They were into CI/CD, so they helped like fintech banks, especially in US, work on their CI/CD pipelines, help them work on code quality. And there, I also got to work a lot on static code analysis. Published a patent on it also. So yeah, that's a brief introduction about me. And now again, moving to Infiless. With Infiless, what we are trying to do is we're trying to help companies that want to deploy machine learning models do it in a fashion like AWS Lambda, where again you just put your machine learning model on autopilot. Once you have trained it, you don't need to do anything. Everything else is taken care of. Right? So that's like a one-liner introduction. Moving to the slide, right? Yeah. So I just want to like take a step back again from serverless and first talk about a little bit more on like how the machine learning deployment scenario is going, right? So we see the world like fairly divided into two parts, right? So one are like these companies like OpenAI, right, where you have closed APIs, right? So let's say you have a machine learning use case, right? You want to let's say summarize a text or uh, create something like a chatbot, right? So here again, like there are some companies which are just using closed APIs, right? So here again, like you're completely reliant on like companies like ChatGPT, Anthropic, and others, right, to give you APIs. Second part is where like we mostly come in, and which is more like custom models, right? So this is where like you go about like building your own model and like fine tuning it on your data, right? So that is what again like serverless deployment only comes in the scenario in the second part, right? So a lot of people ask that, hey, I have a closed API, can I deploy it with serverless? The answer is no, right? This is only meant when you have very custom models which are very trained, fine tuned for your data. So yeah, that's like a high level view. And again, like then the question comes is why did we start betting on custom models, right? Because you have seen like ChatGPT grow so much in usage, right? So again, there are a lot of trigger points, right? I would say why you would want to, let's say, even if you have like an early pilot in, right, ChatGPT, move to like a more custom model, right? So our heavy bet is that we see a future by 2025, there will be like a lot more custom models and it will be like smaller models, right? And again, the trigger point of that is again, if you see like a lot of times, like what happens if the API provider changes the model below the hand or they make some improvement, right? You cannot offer that as an enterprise grade solution, right? Because the underneath software layer, you're not really controlling it, right? So that is, I think, the first trigger point which we see most companies that, hey, I built my application on, let's say, some API, and then the API after 5 days it was behaving differently, right? And so that is like the first point for that is like definitely more control. Like if you want more control over your architecture, how the inference should happen, what should be allowed and what should not be allowed, you definitely want to go for custom models, right? Uh, Second is like again accuracy, right? Uh, although like GPT-4 and general purpose model, right, they serve like well in like most general scenarios, sometimes even better than humans. But there, of course, will be scenarios where it's definitely like uh, more to have like you want to like train it on data which is like not accessible to the web, like for example, health data or some other kind of proprietary data, right? And then again, like for running like a GPT kind of a model, it's like a GPT 3.5, which is like 185 billion parameter model, right? You need a lot of cluster of GPUs, right? So your cost per inference, right? Even if you take from a scalability and a math perspective, it will be super high, right? If you want like a sustainable low cost scalable inference, you have to use the custom models, right? So I'll just take a quick pause here. Any questions about like custom models there?
Yeah, I think there are a bunch of questions people have posted in the chat. I think one is specific to Inferless, which is so Harsh has asked, does Inferless help with customizing existing models from OpenAI? Actually, it's
Got it. No, so I'll answer that. So I think again, this is a great question, right? So again, we get asked these questions a lot, right? So see, if the model is proprietary, right, and you cannot download the model file, right, then services like Inferless or any other like serverless provider, right, won't be able to give you that. So you can consider us once you have the model weights, right, in some file, in some form, right, either like an S3 on a cloud bucket or somewhere, Hugging Face, right? So that is where we come into picture, right? When you say like fine-tuned versions of ChatGPT, those are like proprietary models, right? You can't get access to the model weights there. So right. So even you have fine-tuned your own version on your data, but still the model architecture and the model weights remains with them, right? Yep. So I hope that answer your question.
Yeah, I think Harsh acknowledged that. I think next question from Dean. You want to read it out, Nilesh, or should I read it out?
I think I have the screenshot, so that would be helpful. Yeah.
Okay, so basically, Dean's question is, how we are talking about custom models, but with the launch of ChatGPT and similarly with Anthropic and Cohere launching their own enterprise versions, does the need for custom models continue or not, right? So why would somebody need to make their own models?
Yeah. So of course, let me answer this in two-part answer to this, right? One is, of course, you will not definitely build your own custom own models from scratch, right? But when it comes to fine tuning, right, and even them offering fine tuning services, right? So when you go to these models which are on I would say in the range of 180 billion parameter plus, right? Then although you have an enterprise version where you can send the data to them and chat, do your fine tune. But that also has a lot of dimensions, right? Sometimes because of regulation and security. Like, again, Anthropic does not have a server in every region, in every cloud provider, right? So there are some regions where you just can't send your, like, say, if it's a health data, right? It can't leave like a close VPC system, right? So although they have enterprise versions, which may solve for some use case, but then again, there will always be use cases where you cannot send data to them. Second is that again, you also don't need like so it's like you're building a rocket to go like to the next block, right? A taxi will probably do you as fine as that, and again will also help you save cost, right? So again, here the argument definitely can be made. So this is like a very use case specific thing. So there will be certain specific use case where again, like having even we have seen with people like with Llama 2 release, right? They have like a 7, 13, and a 70 billion model, which is out. We have seen people get like almost equal accuracy with a 7 and a 13 billion than like versus a 70 billion, right? So you want reasoning logic, but again, it depends upon the use case, how much you want it, right? So the answer is, of course, there will be like customized versions of very big models always there for like some complex tasks, but we see 80% of the tasks will be like it can be done with a couple of billion parameters, right? You don't need like 100+ billion parameter, right? So yeah, I think, and then just to like come on the fact again, right? If you see like Hugging Face again, this is in the last 6 months. We just read about their announcement of raising, right? So they say that half of their models are private, and like most of the models which are on Hugging Face are not more than like I would say 30 billion parameter, right? If you see the most like top models, right? Sorry, yeah, Brand.
I was saying Aishwarya, who's the other co-founder of Infalight, she's also on the call, guys. So she might also answer some of the questions while typing. So just to let everybody know about that. So Aishwarya, you're there, and please feel free to answer those questions. Aishwarya made you a panelist as well. So.
Got it.
Yeah.
Cool. So I'll just probably move on. So I think that's like, again, a high level, really great questions on custom models, right? So again, there will be a lot of custom models in custom, like fine tuning is also an option, but fine tuning, I think, as said, right? There's a layer where you can get the model weights and do whatever you want. And there's a version where you say that, hey, you send all the data to like them and then do it, right? So we are more for the version where you have access to the model weights and architecture. Cool. So now I think we'll just switch gears a bit to like cloud deployment spectrum, right? Because like a lot of times people ask that, okay, what is serverless, right? Because like are there servers, right? And like why can't I take a machine and just like build my service on top of that versus like what are you doing? How is AWS different than like Infosys, right? Why don't I take a machine from Infosys, right? So just to like give you a high level spectrum, right? So again, this chart shows like it's just two things, right? If you see the red and the yellow color, right? Red is what you manage and yellow is like what your provider manages, right? So again, the first type of deployment is on-prem, right? Where you have like it's very same example, right? You want to get a machine learning service up. So you go get an NVIDIA RTX A600 or 3090 card, set it up, you control the hardware, you control the virtualization, you control the OS. If you want to scale up, you have to put in more cards, right? And then you can deploy anything you want on top of that, right? So this is the first level, right? And this is, I would say, the level where you have committed for the whole hardware itself, right? Second is like I think the layer where we go to infrastructure as a service. So this is like providers like AWS and GCP, right? So what they do is they have built the hardware and virtualization layer. So you don't need to worry about the real hardware, right? You just like uh, start from the OS layer and go above from that, right? So you install your own software. Then I think there are like next set of things is like container as services, and there are two variations of container as services, right? So when you talk about container as services, this is something like a AWS EKS, where they say that, hey, we will manage scaling based on this. You control the scaling parameters, and then we control the OS virtualization. We'll automatically patch it. We'll send the new updates whenever it goes, right? So here again, you see as we go forward, right? And then again, it comes where you even don't control the scaling, right? Where you just deploy your application. You have access to runtimes, right? So this is where the serverless spectrum actually starts, right? So the first difference between them is that when the serverless starts, you don't manage scaling, right? Scaling is something that we want to be, you don't want to manage it yourself, right? But you still want a control over runtime. Runtime means like software libraries, right? And then there is a Lambda into it, which is function as service, right? Where you say that, hey, I don't even manage the runtime, right? You can install Ubuntu, uh, Amazon Linux, or whatever you want, right? I just want my application to run, right? And there the scaling becomes even more linear, right? And then software services, like you just deploy the whole app and give someone the SaaS, right? So this is actually the serverless spectrum, right? This is the whole deployment spectrum that you can think about, right? And this is mostly a choice that where do you want to like go about, right? You want to manage scaling, you want to manage runtime, or you don't want to manage anything, right? Yeah, so that's like a high level on the cloud spectrum, right? Where you can go about the deployment, right? Now after like we like just understand the landscape of deployment, right? We again, this is like poll from like we did from 200 plus wait list for our service, right? That with machine learning, right? What was their top challenges faced by CTOs and ML teams, right? So first and the biggest one was that their ability to get latency, right? So they have deployed a model. Latency can be a factor of two things, right? Either while auto scaling, it takes too much time, or second is while the inference is happening, right? They're not able to optimize the hardware, right? Second is like GPU utilization, especially in the case of inference, right? Because when you're running training, you can be sure that whatever A100 or H100s you have, right? You have super high utilization. They're actually like you need more of them to train like even smaller models. But with inference, we have seen like the teraflops and the VRAM consumption for most of the GPUs is somewhere around like very low, right? Somewhere around 30 to 50%. And like 50% of the like people have said that they have this problem, right? Uh, the next two are more on the like hardware provisioning and which is the right hardware I should run on. So as you folks already know, right? So if you see the CPU world, right? There is compute which is like very, very, very linear. You can get 0.5 CPU, you can get 2 CPU, you can get 4 CPU, you can get, and then you can configure it with any type of RAM, like 2 with 5 gigabytes, right? But with GPU is like very, very limited. You on the market have more like 5 or like max 8 commercial cards, right? Which you can like run in the spectrum of, right? So, so that makes things harder, right? So, and then of course, like we all know the GPU shortage. I don't think I need to tell them. I think here it's not as highlighted as it is really is. So, yeah, and of course, like keeping a GPU service on, right? It's a like super high cloud bill, right? Because considering you are going for a 800, like even one instance, right? On a AWS, Azure, or a similar platform, which is the like top cloud providers, it will cost you somewhere around like $3,000 a month to just keep like a single replica of a service on, right? And let's assume you have 10 models, so the cloud bill is just insane. So yeah, so this is what like again, before we even started Infosys, right? We spent the first 3 months in just talking to people, and then we have just collected this data over the last 8 to 9 months, I would say, where we have seen like these are the top challenges for like most people are deploying. Cool.
So if Nilesh, if I get this right, what you're also saying is GPU scaling is unlike CPU scaling. Essentially, it's discrete, right? So I can't have like maybe in CPU scaling when you go to AWS, you have like extra small, large, extra large. GPU doesn't work like that because that many configurations don't exist. Is that right?
Yeah, that's a very, I think, good and like a clear observation, right? So yeah, that's actually the biggest problem with GPU deployments, right? That the current availability is very like it's NVIDIA only, like which most CPUs are on, and then like you either have a 16 GB, 24 GB, or 80 GB, or maybe even 40, right? But it's still not as linear as CPU is. Completely correct. And that's, I think, one of the biggest problems that people come with, right? Because model sizes are like, it goes up by a GB, right? So there's a 5 GB model, there's a 7 GB model, there's a 20 GB model, there's a 30 GB model, right? So how do you like bin pack them? That's like a...
Thank you. Folks, please ask
Uh,
your questions in the chat window. That'll be great. We can pick it up from the chat window and we can answer those questions.
Got it. So I think there are a couple of questions on code start, but yeah, I think all of those, I think we'll definitely cover like underlying hardware possible, those, right? Again, here are again some like myths or hard hitting facts, right? When we do custom discovery, and these questions are not like we heard it like a lot, right? So, like the first thing is like, isn't serverless more expensive by the hour than the machines, right? So this is like the first question that we get, that, hey, like I can get this machine like for $1 here, right? Why are you guys charging $3 or $4? So it seems ridiculous, right? But again, like just wanted to like tell that again, machines like are cheap, like cheap machines save dollars, but again, there is a cost of tooling, right? And it's a huge cost, right? And then the second thing that comes when I say this is that, hey, can we just deploy Kubernetes? Yeah. So again, Kubernetes might look free, so it's very easy to get a, let's say, one endpoint up in Kubernetes, but to scale machines and pods and services based on like Kubernetes metrics is really, really hard, right? The kind of setup it needs, you'll need like a DevOps team to manage it. Then like it's just super, super hard, right? So we want companies who are like really trying to build generative AI models, right? Stay as much away from Kubernetes as you can, because again, it's meant for infra companies. It's like something that might look simple, but will explode in costs, and like, because there you pay by the hour, right? Uh, uh, so yeah, so that's like these are like two of the hardest hitting facts that we come up with. So, and I'll explain you and why the costs are like higher, right? Because there is a service level to it. Cool. Now again, coming to the area, I think one of the hottest topics, right? So again, we don't recommend like serverless as the go-to tool for everything, right? Of course, there are scenarios in which you can just deploy a container or a Kubernetes and it will work as well. And it might be a equal cost option also, right? So the real benefit of serverless is like when you have very unpredictable usage, right? So when you have like super spiky loads, that is where I think that should be your first mental cue to go with like something like a serverless solution, right? Because what happens is like with spiky loads, like you don't know when the most of the requests are coming, right? And what most of the serverless providers do is they have a warm pool, right? The warm pool is super big. So let's say you scale from 0 to 20, 30, 40, 100 requests, right? They have a warm pool where they can just start, those instances are already on and kept alive for them, right? And then you just like put the service on and then give them linear scaling out. With like container as a service, this is not possible. The most inhibiting factor is the machine start time, right? If you take any cloud provider, it takes around 1 to 3 minutes to even start a machine and give you that instance. Second is right when real-time latency is critical, right? So typically, like scaling up of a Kubernetes container service takes like order of minutes, but when you have demand which comes in seconds, then that's like a thing that you should definitely think that, hey, if I want my auto scaling to happen in seconds, that is when I should think about serverless. Second is right now we would say the model sizes like 1 to 30 billion parameter. That is what is optimal for deployment. Anything which is bigger than 30 billion parameter, yes, you can still do it with serverless, but again, the switching cost will be super high, right? Because this is like you're talking about like 50, 60 gigabytes, putting it on and off memory. Right? So in that case, you're probably better off with yeah. So again, as I said, like just recapping, right? So if you have very predictable road, containers are equally good options, right? And if you're able to do bin packing well, you can achieve a high GPU utilization. If you have a batch use case, then if latency is not critical, then again, you can write your own orchestration workflow of starting a container and stopping it, and then even say so for the machine, right? There are very good services in AWS, Vertex AI to do batch very well, right? Cost optimal. And third is, of course, like if you're running a 100 billion parameter model, don't think of serverless, at least not now. The third point is something that we are also working on. But again, currently, if you are in that range, we would suggest that it's better to think about another way of deployment. Cool. Yeah, coming to some of the common use cases and like customers that we have seen, right? Where we see like a serverless use case, right? And again, these are like things which are very, very, very spiky in nature. First is the customer support bot, right? Because like once you have launched a product, support is something that goes very variable, right? And it's usually in the business hours. Like we see like companies who have deployed with us, like there is a time of like 10 to 1 p.m. where it's spiky. There is a time of like 3 to 6 p.m. where it's spiky. Other than that, it's like more or less the flat line, right? So when you come across these kind of traffic patterns, like it's serverless is like super good. It will help you save a lot of money if you have such a scenario, right? Second is when you have a lot of B2B customer specific models, right? This is where like there are companies who, let's say for each customer have a very specific model, right? Now, let's say if you want to host 1,000 models, right? And each model is, let's say, assume 10 gigabytes, right? So then the model size, like then you will need like a fleet of GPUs, which is super high, right? This is also where like serverless makes sense because very like each model, if you see, they will be very infrequently used, right? So this is one of the like customer personas that we very much match with. Second is more around document abstraction. These are like PDF-based chatbots where you need like very high performance and like ability to run, let's say, Llama kind of models. And then, of course, there's consumer photo editing apps. This is also like people who are like app-based photo editing, background removal. So these are all GPU-powered experiences and have very fluctuable workloads, mostly using stable diffusion kind of models, right? So yeah. So yeah, these are some of the common use cases here, right? And happy to like take any cases which you think you would want to understand.
Yeah, Nilesh, one question, and we should probably take some questions from the chat. I think Aishwarya is answering them. But one question I had was, let's say stable diffusion, right? Very heavy to run. Obviously, I think couple of GBs, and actually the inference cost is very high, right? So you've written consumer photo editing apps running on serverless. How should a founder think about this, right? Is like why is, let's say, serverless using serverless better versus, let's say, hosted stable diffusion APIs, for example, maybe?
Got it. Yeah, so that's a great question, right? Especially choosing between hosted stable diffusion APIs and like using something like deploying a stable diffusion with us, right? So here we have seen, right? So most of the companies who are building like consumer stable diffusion use cases, right? They don't take out of the box deployment, right? So if I talk like open platforms, right? Let's say Stability, Replicate, right? There are two versions, right? Either you can take a API which they have already deployed, so they have a already like deployed pool of like 10-20 models, where again the pipeline is not custom, right? So it's like whatever code they have written. Now when it comes to like these startups, right, we have seen they usually have like a control net version of it in which they have done either like some weight tuning, or the pipeline is changed. So although the model is still stable diffusion, but the pipeline and the scheduler and all of those are changed, right? Now, if you want to deploy that, you have to deploy it as a custom model, right? So whenever your pipeline becomes like very, very, very custom, not even the model weights, then also you have to look for a custom deployment provider, right? There we have scenes like, so I think someone also asked about replicate versus us, right? So I'll just also like ask. So for consumer photo apps, so let's say if you have a experience, right? So currently we have been able to get the cold start of a stable diffusion model like in under 7 seconds, right? That's like our best benchmark we have done for stable diffusion, right? So now if I talk about the consumer experience, right? So here latency is super, super, super critical, right? So let's say if you upload an app, right? And if, let's say, you fire an API on, let's say, one of these providers like Replicate, where you have a custom model, right? So it takes right now in the order of 1 to 3 minutes for the response to actually come back, right? With us, it's still in the orders of like seconds, like 15, I think 15 seconds, you get the image plus the cold start, right? So this is where like deploying it on a serverless low latency really makes sense, right? Because if you can still like get the in under 10-20 seconds, and for some people again 15 seconds is also a deal breaker, so I totally agree with you folks. But if you can like get that 15 to 20 second buffer, right, you can actually save a lot. Because if you have to keep one instance of GPU on for the whole month versus us, we would cost you like approximately like 40 to 50%, right? And then we can do as custom pipeline as you want, right? So you can put whatever code you want, you can put whatever kind of control net you want, whatever scheduler you want, right? And those are some applications that we have seen really good success with.
Thanks. Yeah, I think we can move forward.
Got it. So yeah, what I will do is I'll probably like again here I think we have a lot of early stage founders also, so I can help them with probably, let's say, I've taken an example use case like of how you can think about inferless in your whole stack of solution, right? Uh, um, so here again, this solution is again like this is like a document extraction use case. So you can assume like a customer has uploaded a PDF and then he's asking some questions about the PDF, right? So this is like you're extracting knowledge from a particular. This is the use case, right? So again, let's say like you start a service, right? And on a day one, you are having 10 to 20 documents a day, right? So now let's say if you have to deploy this solution, right, where if you upload a document and then you can do like a Q&A managed text extraction on top of that, right? So how we see a typically good infrastructure is that you use S3. So you use your UI where you use your UI to push the data to S3. And then from S3, what happens is like event gets triggered that, hey, I have the document. And then what it can do is AWS Lambda, since it's serverless CPU, it can trigger a call that, hey, I have the bucket. So now I want you to like do the encoding of this document and keep it ready with you. And then with each like step function, let's say if you have like lots of Q&A, right, you can run them one by one. And once your whole thing is done, then the inferless will automatically scale down your document extraction model to 0 down. So this is how you can set up like one model so that you can do like document encoding, decoding, and then use step functions to extract the questions from the document. Right? So happy to answer any questions. Sorry, yeah. So yeah, so I think how we want to think about people is like we want them to think about us as a like a Lambda equivalent, but only for machine learning models. Where you, if you have a completely event-based system, right, or you don't want to like have any fixed recurring cost, especially in the early days, right? Inferless can help you like largely, where you don't have to like worry about like, hey, I have a $5,000 endpoint running, so I'll probably exhaust my credits. So that's how we can think about it. Happy to take any questions like understanding how the event architecture or anything that you can build on top. Cool. I'll just go for the next one then. Cool. So I think one of the again like big questions that we usually get hit on in Infiless is about like how does cost look like? Like since it's serverless, it must be pricey, right? So I just wanted to like show you a deployment of the same use case that we did, right? So how does the cost look like for some like such a solution, right? And especially let's take Llama 2 as an example, right? Because we have seen a lot of our like current early customers use Llama 2 for document summarization and extraction. So let's say we have chosen a card which is like a 24 GB VRAM, 810G card, NVIDIA, which is like a G5 2x large instance, right? And let's say you want to deploy like a single endpoint, which I showed there, with AWS SageMaker versus us, right? And then we have done some load assumptions right here. So one is that let's say we have done a load of like 1,000 docs a day. Each docs, let's say, takes 20 seconds of processing. So, like, let's say if you had to just pay for the seconds you were actually processing, it will be 5.5 hours, right? But then again, it's not just like serverless just doesn't charge you only for the inference, right? There are other costs also when it comes to serverless, right? So serverless, you have a scale down delay timeout, right? So let's say you can configure, let's say once the first API calls comes, and once you have processed the documents, how much time more it can run for, right? So let's say you have set up a scale down delay of 1 minute. And now, so now it's a completely event-driven system. Whenever the docs will come in, it will process the system and then turn it off, right? So if you see with this projection, right, we see like, let's say if you pay 1.1 hours for the ideal timeout where your machine is actually not running, and 5.5 hours where it's actually doing the work of document extraction, right? The total billable hours for inferless will be 6.6. Whereas if you deploy a serverless where if you deploy the same endpoint, LLM endpoint on AWS SageMaker, right, you will be billed like for whole 24 hours, right? And this is like a very optimistic load for a single machine, right? So definitely, like even if the per hour rate looks higher on serverless, but if you see it amortized against like a pattern of usage which is spanned across a month, right? You will definitely see somewhere between like 40 to 60% saving, right? And this is a math that people find it hard to do, right? Because they see that, hey, my price per hour on AWS is 1.5, on Inference it's 2.1, right? Why should I go with Inference? It's higher, right? But it's actually not higher, right?
I think
Any
we have.
questions here on? Yeah.
So you've compared this with SageMaker, but let's say, so one question, Nilesh, from my end, and this as a VC hat, right? The marginal cost of at which AWS will procure GPUs will be much lower, I think, than let's say Inferless, which is a
Yep, yep,
startup, right? So
yep,
wouldn't they
yeah.
pass on? Wouldn't their, let's say, Lambda GPU service be much cheaper than that for Inferless? Like, because you're comparing it with SageMaker, but
Yep. So again, like from a theoretical perspective, yeah, for sure, like big cloud providers will always have an edge on the hardware procuring, right? Because there is no way like you can beat around that, right? But the second question comes to software, right? So the reason again we started Inferless and why Inferless like makes sense, right? Because it's about the latency, right? So let's say we have seen like AWS also has like a serverless inferentia, which is right now only limited to CPUs, right? But even with GPU providers like giving serverless, right? I think there are a couple of providers out there which also do serverless, right? The critical thing here, the crack is the latency, right? And that is like a pure software company, right? So let's say even if we say that we actually today go and buy our hardware like EC2 machines from AWS itself, right? But still people come to us from SageMaker, right? And the reason for that is like, can you get the latency of a model in a way that the consumer use case can really use it, right? Because let's say again, coming back to the photo editing app, right? So let's say if you have a photo editing app and right now you deploy it on SageMaker, right? So there are only two ways you can paying for. Either you are paying for always on, or if you have a serverless or like auto scaling enabled, then you have to take a 3-minute cold start, right? So that is something where like Inferless would still make sense to like even pay a higher price and then get a very linear scale. So it's all about the like how lowest latency you can get on a hardware. Let's say we are even a 50% down, but if we can still get the latency better, the consumer will still choose us, even if it's a higher number, right? And of course, at scale, like in like I think of course in the early days, Inferless will always have a hit on the GPU procurement margin, but that is something like again for a later point. So yeah.
thanks. I think there is one important question which I think we should repeat for the audience, which is, does Inferless build on top of like can existing CSPs, or like they can rent, so a person can rent GPUs from the CSPs, or you provide the entire stack So can they just take the inference, the
Software
running
layer.
the serverless one? Yeah.
Yeah. So no, that is something I think that again we are not. So as a first thing, we are doing like solving the serverless and latency on our cloud, but definitely like as a future, we definitely see in like there's a lot of value in that, and like there are a lot of industries also that have a legal requirement that hey, I want to like probably use Inferless, but I want it in my VPC, right? So we are definitely thinking on that directions. We don't have like a set release date, but that is something that's definitely on our roadmap, right?
Yeah. Thanks.
Cool. So I think we have talked about the cost. I also want to like now double tap on the latency, right? Because cost and latencies are something that like just go together, right? If you put infinite cost, you can get as much low latency as you want, right? So now taking the same document extraction use case, right? So assuming that we are doing like 100 docs a day, and now let's assume 20 docs come at the same time, right? And this is not a very unusual scenario, right? For this kind of a load company we have seen. So now let's compare, let's say, even if you have done an AWS SageMaker, right? How would that look like as compared to instance, right? So now you have, let's say, first scenario is where we have said that, hey, I have done one instance. I don't want to pay more than $34. Then how does my total time to complete processing of these documents look like, right? Let's say with Infiless, you have set up a concurrency of 10, right? So now if you see, even though Infiless has a cold start, the total time to complete all documents. So let's say you have put a request for 20 documents, it will come back in 400 seconds versus on Infiless, it will come in 60 seconds because there'll be two parallel requests of 20 seconds each. And then let's say for all 10 instances, you'll get a 20-second cold start. Right? So this is how like overall with latency, scaling with Infiless is a lot more linear. Right? And then there is no extra charge for this, right? You don't have to pay extra, right? So this is how like the latency also scales up, right? So it just helps you get much more linear there, right? And then again, I would also compare another scenario where let's say we have like enabled auto scaling on SageMaker. Let's say we have set them in replica as 1 and max concurrency as 5. And then let's say we have also like done this like the same setting on Infiless, right? Just like for Apple to Apple comparison. There also see like the time it would take to complete all of these 20 docs would be like 240 seconds versus Infiless would be like like 100 seconds, right? So even though you are like, and here you have to actually pay for those 4 instances for the amount it runs, right? So you have to pay for 5 minutes into like those 4 instance prices pricing also, right? So it's a solution which is both, right? For the companies who don't want to really manage scaling, you'll get the best possible like total latency and then also like individual latency, right? Just wanted to like put that up. Cool. So I'll just probably go on the next part again. So again, what would like the ideal serverless deployment look like? Right? So ideal serverless is again like a multi-model, and it works on like multi GPU for max utilization, right? So that was like one of the key things that we wanted to achieve. And second was like again switching between the models with the lowest possible latency. So these were like some of the things that we had to build from scratch. And then we wanted like framework agnostic so we can support anything. We wanted like very metric driven scale. So we have like auto scaling based on number of API requests and GPU utilization and a lot of other things. And then we also like most companies also ask, can I do dynamic patch with serverless? Yes, you can. So yeah, it's like, and I think yeah, these are like cold start again. Like so, cold start again is super hard problem here. It's even harder than it is for AWS Lambda. Only for the fact that the model so code typically is between 10 and 100 MB like range, right? Whereas model starts with like the smallest model is like a couple of hundred, like 500 MBs, and then the largest one goes to like even 70, 80 gigabytes, right? And then the runtime for these models are also super complicated, right? So let's say if Python whole execution backend runs in like 300 MB. PyTorch and TensorFlow are like much bigger libraries to set up, right? And so I just wanted to explain like why are there so much penalties? Why is actually AWS has not already done it, right? So there are like it's a lot different challenges and it's a lot harder challenges than like building a simple AWS Lambda, right? So yeah, and I think the fourth one is the biggest one, which is like getting the best ROI from infrastructure, right? Because uh, like at the end, if you're not able to programmatically scale up and scale down your infrastructure, right, you can offer like a service, but then again, your GM and everything will just go down the drain, right? So yeah, these are some of the challenges of running a serverless company. And I think I got also questions that why can't I do it? You can do it, but it's a company within your company. So I would not highly recommend it in the early days. And even in the later days, I would say like stay away from it as much as you can. But of course, at some point, if you definitely need cool. So I'll just like explain you how like the inference, like how we build the whole platform, right? And this is like not our architecture diagram. Just FYI, this is not like this is the oversimplified version of it. Some of it is pretty like proprietary, so we can't share much. But this is how you can assume like inferless to be, right? So it's actually like for you, you can treat it as a black box. So you basically query anything you have. Then we have built our like custom load balancer, which acts as a router to your request. Then we have like a infrastructure map where we know like which GPU runs where, and then we redirect your request to the right machine, which can serve it in the lowest possible latency, and we give you the result. Other side of it is just model repository. So we have figured out a way we can get PyTorch, TensorFlow, or any kind of material directly like in the pods. Like that is something that we manage ourselves. So you just give us a model and then you run it with application queries and predictions, right? And then we do the inference part, we give you the result, and then you don't have to worry about anything else, right? So this is our like starting point. This is what you can assume inferless is a big box of this prediction service, which internally has everything. Right? Cool. Again, so some of the unique problems again that we solved was, so one of the again key challenges, as you might have seen, is like how do you put the model weights into GPU memory, right? And like people ask also, how are you able to get like inference in like seconds, whereas like other people take like minutes. So it's a like a very multi-tier caching layer. So there's a lot of layers of cache in terms of from S3 to persistent storage to like storage very close to the GPU, right? And then it's like actually like a huge complicated architecture setup, right? That to like reduce this latency, right? And for the teams who are planning to like build themselves, this will be something that they have to like individually solve, right? And these are very like low level architectural problems, right? Second is auto scaling, right? So you need to create your own load balancers where you have like the idea of determining at every point of time that where the request should actually go, right? And like most of the load balancers that you get with AWS, they're very like round robin based or dumb, right? So you have to really put a lot of effort to make sure that you figure this out, right? So these were the two unique problems that we solved. Uh, I think we can just go through a quick demo of the product and show you like how you can probably get like a stable diffusion kind of uh, like stable diffusion kind of endpoint live with us. Right? So I'll just probably go through it. Happy to take any like questions post that. Cool. Uh, I think let's go back. Cool. So guys, can you, if you are able to see my screen, sorry, I think this is running a little bit faster.
We can see the personal workspace of Inferless, which you showed. Yes.
Got it. Yep. So this is how I think the Inferless workspace looks like. So once you log in, you have all the models that you have previously deployed. You have endpoints for them ready. Importing a new model is super simple. I'll just walk you through like how you can get a model from Hugging Face working in like less than 3 minutes. So once you start, basically you first start with the Hugging Face model. You paste the link. Then we have the option of like adding a model. You can quickly add model. We have support for 3 types of model. This one is on PyTorch. We can import it from multiple places. So we can import it from AWS SageMaker. We have GitHub if you want to like directly import a file. We have Hugging Face. So if you're in Hugging Face, you can just like paste the Hugging Face model repo name, call it whatever you want to call it. Let's say if it's a diffuser model, you can call it diffuser, and then you can see this. We also have the option of you can do parameters here. You can set up like whatever you want. Prompt is one parameter. You can also set up like image size, number of inference steps, and then it will quickly just validate that you have access to this Hugging Face repo, and then move to the next step. Next is where here you choose like the infrastructure. So we have A100s, we have T4s, we have A10Gs, right? Then we also have the option of, let's say, we talked about the bin packing problem, right? So you can also use half a A100 to deploy, right? Where you get the same latency, but you use 50% of the VRAM, right? Uh, 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 so yeah, so this is how you can go about like selecting the machine type. Then we have scaling. So let's say you can like to deploy it in a completely serverless fashion, you can make it 0, 1. But let's say if you have some requests throughout the time, right? So you can also like set up a min scale, which like those machines will already be running for you, and then we'll scale as the request comes in, right? We also have like CI/CD, so you can integrate with GitHub, you can integrate with Hugging Face, and then you can just push your models here. We'll automatically pick them up from there. You can also like give all of your software requirements like a requirements.txt file, where we'll get like all the Python and other software dependencies you also need. And then you can specify the vCPU and RAM. Let's say some people have pre-processing and post-processing functions, which are on the tensors, right? So you can also like deploy that with us. Let's say if you're using a third-party service and you want to do some authentication, you can also add environment variables and pick them up in your code. And at the end of it, we basically show you the whole review page. And once this is up, the endpoint is live. You get an endpoint which looks very similar to this. You have an API endpoint, you have a workspace token. We also have made like a quick playground where you can just like type the input and output and like do those testings, right? So you can just run this. We also have like things like logs, metrics, and everything else. And so basically what we do is we generate like a app.py file for you, which you can also later customize yourself. So you have the initialize, infer, and finalize function. So you can just like go about that, and then yeah, it just generates the image, and you can copy the image and like, see the message going on. So yeah, that's like how you can get a endpoint quickly up, and like then this is like the image which I predicts. This is how like the whole Infiless platform works like, right? So it's very simple. You can get your like model deployed in like under like, yeah.
So,
Yep.
Nilesh, like how much of this is sorry, jumping in for the audience, let's say, do we need DevOps engineers? How sophisticated the team should be to use Infiless? Some of that could you cover? Like how small a team can use Infiless? How difficult is it
Yep.
to ramp up?
Got it. So yeah, so when we again designed this platform, we wanted to mainly focus on like data scientists and ML engineers. So if you have the ability of, let's say, running a Jupyter notebook, right, where you have, let's say, trained and run your notebook, you just need to like change that like into like 3 functions, and then you can just integrate that code with us, right, through any method. So this is how simple it is. So we have seen ML engineers without DevOps team actually like deploying models on us, right? So the idea and user persona for this is definitely ML engineers and data scientists, that they don't need to go to a DevOps team to deploy these workloads, right? So yeah, makes sense.
Thanks. I'm not sure if compare. So one question is, how does it compare to model.com?
Got it. Yeah, so I think I think we get this question a lot, and again, like kudos to Model. I think it's a great platform for also deploying machine learning workloads, right? But what I think about is definitely is that like Model.com is like AWS for GPUs. You can consider us as AWS Lambda for GPUs. So that's where we see the positioning difference, where they are helping you do everything. You can deploy webhooks, you can deploy containers, you can deploy everything. But what we do like is that we get the like for us the latency of like a stable custom stable diffusion model is like something that we really get, which is like better than like most people, right? So if you want to get serverless and like get the lowest possible cold start, then you think of us. But of course, if you want everything like AWS, then model is also like a great option.
Awesome. Folks, please send your questions in.
Yeah, I think this is it from my side. So I'll probably like stop the screen sharing, and then yeah, we can just take a Q&A.
Okay.
Oh, I think there was one more slide. I think so. Yeah, I think we are open to our like wait list. So if you guys wanna just like get on the wait list, try the software out, you can definitely go for this QR. Yep, there's a QR code here, and like if you guys want to like try the platform out, if you have even more questions, you can sign up for our waitlist. Just launching in like 4 weeks from now. So we already have a beta version live, so we are like piloting with customers. But like yeah, if you want to sign up for the waitlist, you can. Cool.
There's one question from my end. Do you think the stacks, inference stacks for LLMs will be very different from the inference stacks for, let's say, audio or for images? Like, but I'm asking a very dumb question.
No, I think that makes sense. So I think here there's a finer layer to this. So what we see is like you will find like a very successful probably LLM company that just does LLM for different use cases very well, right? So again, in terms of like GPU, right, it's the same thing, right? At the last spectrum of it, right? It's just an inference endpoint, the model code wrapped, right? But what we have seen is Stable Diffusion has a different kind of a CPU GPU requirement, and then like LLMs have like a slightly different, right? LLMs are more VRAM heavy, uh, Stable Diffusion are more compute heavy, right? So that is like the difference in inference stack, and the kind of GPUs and the orchestration you need is a bit different for them. But it's not like super different. So we do see companies, let's say if you want like a replicate kind of a company that just has like 20 LLM and you can just choose and pick. So that is definitely a company that will also probably come in, which is like very specializing in LLM. And then same for like Stable Diffusion and like image generation use cases, right? But again, when it comes to like custom models and pipelines, like let's say video generation, AI generation, all of those are like pipelines built on top of these models, right? So that you can actually deploy anywhere, right? So we have seen more and more people do that on like custom pipelines or like AWS SageMaker kind of like tools when it becomes like too custom.
Awesome. Thank you. Let's see, folks, any more questions? I think
We can take one or two. Yeah.
I think chat is going on. I think people are writing on the chat, so that's great. Yeah, I think it's a common, it's the most obvious question, right? Are there no offering for serverless on GPUs on Azure or AWS or GCP?
Yeah, so on the big tech, there are none for sure. And again, uh, like AWS Lambda was again purpose built, right? The firewall VM, and I knew that team very well, right? I worked at Amazon, so it's like they have to literally re-architect everything to get like GPU serverless, right? Because it just starts with a very different virtualization layer, and it builds up ground there for them, right? So right now, like if you want to deploy with them, the best you can get is like deploy a EKS cluster and then manage nodes there. Even Fargate or Lambda currently doesn't support like GPU. With Azure, the only thing you can get, sorry, not Azure, with GCP, what you can get is you can have like Cloud Run where you can like do things on that, but the latency for the instant start there is like 2 to 3 minutes, right? So if I talk about a sub-minute serverless system in all three tech providers, it's not there.
Yeah, I think to Tuhin's question, what is hindering big tech is probably NVIDIA is not willing to share the GPUs with all of them. And
No,
like
I think so. Yeah, I think the answer is there. It's a twofold. So I think one is definitely like if you see it's hard to get an on-demand instance in also, right? So if you see the evolution of serverless, right? Lambda didn't happen on day one, right? CPUs existed from like 2000, 2005, right? It took them 10 years to like get there, right? So definitely they will get there. It's just that the demand for on-demand is like super high, right? People are not able to get on-demand instances. Serverless is a something that comes once you have like too many hardware or infra which is already. So it's a like a cost. It doesn't make sense for them to do it from a P&L and a cost perspective because they're minting money like selling RI instances. So yeah, for now. Yeah.
awesome. Thank you, Nilesh. I think thanks for doing this. Guys, it's 1 hour. I don't want to stop Nilesh. I think this is an interesting conversation which can continue on. Thank you for doing this a lot. I think we have, I'm also waiting for the Infoless launch and hopefully a lot of people will join up. But thank you. I think it's much more, I think the fundamental thing that GPU serverless is very different from CPU serverless is the core of the matter, right? So I think that's something to think about, and it will probably evolve very differently. And we also discuss the stacks are different for different AI inferences,
Yeah, yes.
model inferences. I think that's great. Thanks a lot, Nilesh. Thanks a lot, Aishwarya, for taking out your time and doing this webinar for us and our audience.
No, it was great. I think there were a lot of myths in serverless. I think we're happy. I think there was I was just like looking at the chat now, so I think it was a flowing list of questions. So that's super, I think, interesting. And I think this is definitely like serverless is not like not without debates, right? There are always debates. Should we go serverless? Should we not go serverless, right? So it's always a debated topic. Again, what my parting sense is, you should only do it if you like plan to do it for like a long period of time, right? You should not like say that, hey, let's today do it on one thing and then not think about scalability, right? So until you have like a matured, like a very, very, very matured, like AWS kind of a team, you should not think of building this yourself because of course you will be able to solve it, but maintaining it also is also like a big challenge. And then for getting the latencies to where you would have to do for a commercial use case, right? It will take a lot of time. And it's just not right for all companies to solve the same problem, right? It just makes sense for one company to solve it and then others to use that. So that's just
awesome. Thank you, Nilesh. Thanks for doing this. Thanks all. And thanks, Aishwarya, as well. So we'll stop here. Thank you. And we'll make the recording available in the next, hopefully next couple of weeks, like 10 days or so, we should be able to put this out. We're just launching our YouTube page with all the recordings of previous webinars as well. You should be able to get it there.
Yeah. Awesome to see like more AI generative companies coming up, right? Like we would want more of them. So shout out, thanks Priyank for running the AI cohort, and especially for India, right? We want like more people from India building like a lot of custom deep Gen AI companies. Yeah.
Awesome. Thank you.